Look at your hands right now. If there is mud, grease, ink, or dust on them, you probably think that dirt is sitting on you. When you see a smudge of grease on your skin, your brain tells you a very simple, very convincing story. Your brain says, that dirt is physically touching my skin. If you walk over and press your thumb against your smartphone screen or a clean mirror, you think you are taking biological oils and physically stamping them directly onto the surface of that glass, the exact same way a rubber stamp presses ink onto a piece of paper. But you aren't. If you watched my previous lectures, you already know the uncomfortable truth about solid matter. You know that electromagnetic repulsion prevents the atoms in your body from ever making physical contact with the atoms of anything else in the entire universe. But instantly, you brilliant people flooded the comments with a spectacular, undeniable paradox. You cornered me. You asked, wait a minute, if we never actually touched the desk, how do we leave a fingerprint behind? How do my hands get dirty? If I've never touched anything in my entire life, how is there mud stuck to my shoe right now? It is a beautiful question. Your brain demands an easy mechanical answer, but the truth is, dirt isn't touching you. Fingerprints are not physical stamps. By the end of this video, your understanding of cleanliness is about to be completely shattered. You will understand the terrifying reality of chemical adhesion. You will learn how invisible molecular bridges form in empty space, trapping dirt, mud, and oils in a microscopic magnetic hostage situation without a single atom ever making physical contact. Let's start by addressing the biological lie that you are currently living inside of. You spend your entire life trying to stay clean. You wash your hands, you scrub your floors, you wipe down your kitchen counters. When you see a stain, your immediate instinct is to apply physical friction to remove a physical substance that is touching your physical property. We are obsessed with contact. We are obsessed with the idea of solid things bumping into other solid things. Push your hand down on your desk right now. Go ahead, push hard, lean your weight into it. Why doesn't your hand go through? If I ask you that, you'll probably say, because the desk is solid. Wrong. Not wrong because the desk isn't solid, it is, but wrong because that's not an explanation. That's just another label for the thing you're trying to understand. Try again. Why don't the atoms in your hand pass through the atoms in the desk? You might say, because atoms are solid too. Stop. Think about this. Atoms are not solid. An atom is mostly empty space, and when I say mostly, I mean it in a way that defies human comprehension. If you took a single atom from the skin of your finger and scaled it up to the size of a massive professional football stadium, the nucleus, the protons and neutrons, the only part of the atom that has any real mass, would be a single pea sitting directly on the 50-yard line. Where are the electrons? They are tiny microscopic dots way out near the uppermost bleachers, buzzing around in a cloud of probability. And everything in between the pea on the 50-yard line and the electrons in the bleachers, it is empty. It is a complete, terrifying void. Your hand is essentially all empty space. The desk is essentially all empty space. The dirt on your shoe is all empty space. So why don't they just pass right through each other like two ghosts walking through the same hallway? You are starting to get uncomfortable now. Good, you should be. The answer is the electromagnetic force. The electrons in the bleachers of your hand have a negative charge. The electrons in the bleachers of the desk have a negative charge. And the universe obeys an ironclad rule, like charges repel. When you push down, you are feeling trillions of tiny electromagnetic interactions pushing back. You are feeling fields of energy refusing to overlap. Your hand never touches the mug. Your hand never touches the desk. Not really. There is always a tiny gap between the atoms in your hand and the atoms in the object. You are not feeling contact. You are feeling the electromagnetic force pushing back at you across a void. So if there is always a gap, if you are permanently hovering a fraction of a nanometer above everything you interact with, how does the fingerprint cross the gap? How does the dirt get on you? To understand why dirt sticks to you, you first have to deeply, truly respect the force that is keeping it away from you. You have to understand how violent and monstrous the electromagnetic force actually is. We've become so familiar with the everyday world that we've forgotten how absolutely insane the underlying physics really is. We think of gravity as a strong force. Gravity holds the planets in orbit. Gravity pulls you to the ground. Gravity feels powerful. But compared to the electromagnetic force pushing your atoms apart, gravity is a joke. Take two electrons, place them exactly 1 centimeter apart. Gravity is trying to pull those two electrons together because they have mass. The electromagnetic force is trying to push them apart because they have the same negative charge. Which force wins? The electromagnetic repulsion between those two electrons is about 10 to the 42nd power times stronger than the gravitational force between them. That is a 1 followed by 42 zeros. It is a number so incomprehensibly massive that human language fails to describe it. To an electron, gravity might as well not exist. It is completely irrelevant, meaningless. Electromagnetic forces are everything. So here is the obvious question. If this repulsive force is that monstrously strong, why isn't everything exploding? Why doesn't the dirt just violently tear itself apart? Why doesn't your body violently tear itself apart? The answer is almost magical cancellation. Inside the atom, you have the positive protons in the nucleus and the negative electrons in the bleachers. Positive and negative. Opposites attract, like repels like. The forces are exactly equal in magnitude. The push of the repulsion equals the pull of the attraction. In normal matter, in the desk, in the mirror, in the dirt, you get an intimate mixture of positive and negative charges packed as close together as physics allows. Every positive charge is perfectly surrounded by negative charges. Every negative charge is perfectly surrounded by positive charges, and they balance out. The enormous repulsive forces are canceled by equally enormous attractive forces. The net effect is zero, but the forces are still there. Those monstrous 10^42 forces are still acting, held in a delicate, trembling balance. And because the underlying forces are so unfathomably huge, even the tiniest, most microscopic imbalance in that cancellation creates effects that you can feel in the macro world. This is the secret to why dirt sticks to you. Dirt is not a failure of repulsion. Dirt is a microscopic imbalance in the electromagnetic cancellation of the universe. Before we zoom in to look at the molecules of the dirt itself, we have to deal with your brain. We have to deal with why you accept the idea of touching a desk, but find the idea of hovering dirt so profoundly uncomfortable. Pick up two magnets, North Pole to North Pole, bring them close together. You feel that push, you feel that invisible resistance in empty air. You can look right in between the magnets. You can see the gap. You can slide a piece of paper through it. There's nothing there. When you feel that magnetic repulsion, you think it's weird. You think it's mysterious. You ask, why do magnets repel? You want me to give you a familiar analogy. You want me to say magnets repel like rubber bands or like springs. But here's the truth that nobody tells you. The force that stops your hand at the desk's surface is the exact same force that makes magnets push apart. It is not similar. It is not analogous. It is identical. It is the electromagnetic force. So why does pushing on a desk feel normal, but pushing two magnets together feels like magic? I'll tell you why. You've been pushing on solid objects since you were 6 months old. By the time you were 2 years old, your brain had built up an enormous library of experiences, pushing blocks, grabbing toys, falling down, hitting the ground. Your neurons wired themselves around those experiences. They built patterns. They built an intuitive framework. Your intuition evolved to throw rocks, pick fruit, and avoid predators on the African savanna. It did not evolve to understand quantum fields. So now when you push on a desk, it feels natural. You don't think about it. You call it contact. But contact is an illusion. When you push on the desk, the electrons in your hand repel the electrons in the desk at a distance, a tiny distance, a few atomic widths. We call it contact because the distance is too small for your human eyes to see, but it's not contact. With magnets, the gap is bigger, a centimeter, an inch. Big enough to see, big enough to make you uncomfortable. But the force is exactly the same. The mechanism is the same. The only difference is scale. The weirdness is in your head, not in the physics. You have to accept that all forces you have ever felt are electromagnetic. Every push, every pull, every sensation of pressure, every time you bite into an apple, every time your car tires grip the road, it is all electromagnetic repulsion and attraction acting at a distance through empty space. Once you accept that the universe is made of fields that permeate all of space and that particles simply push and pull on each other across those fields, then and only then can you understand what a fingerprint actually is. Let's look at the fingerprint. You think of your fingerprint as a physical stamp, a solid object. But let's zoom in on your skin. What is actually sitting on the surface of your finger right now? Your body is a chemical factory. Your skin is constantly secreting a highly complex cocktail of molecules. You are sweating out water and salts. Your sebaceous glands are pumping out sebum, a mixture of lipids, triglycerides, and fatty acids. You have dead skin cells constantly shedding. These molecules are not neat, tidy little balls. They are long, chaotic chains of carbon, hydrogen, and oxygen atoms. And just like your hand hovering over the desk, these oil molecules are not actually touching your skin. They are hovering. They are trapped in the microscopic void just above the surface of your skin cells, held at bay by the 1042 repulsive power of the electrons in your skin. Wait. If everything repels everything else, if the oils are constantly being pushed away by the skin, why don't the oils just fly off your hand and float away into the room? If you are a walking electromagnet of repulsion, why does the dirt stay near you? And more importantly, when you bring your finger close to the mirror, why does the oil jump over to the glass? Because as we discussed, the electromagnetic force is not just a shield that pushes, it is also a tractor beam that pulls. And this brings us to the strangest, weakest, and most profoundly important force that you interact with every single day of your life. A force that dictates why paint sticks to walls, why geckos can walk on glass ceilings, and why you are currently covered in dirt. Let me introduce you to van der Waals forces. Picture one of those long, chaotic oil molecules hovering just above the atomic surface of your skin. It has a cloud of electrons buzzing all around it. But here is the critical secret. That electron cloud is not perfectly uniform. It is not a perfect still sphere. The electron cloud swashes, it jiggles, it moves back and forth across the molecule, constantly fluctuating in the quantum void. Because electrons carry a negative charge, whenever that cloud swashes, the electrical charge of the molecule changes. For 1/1000th of a second, more electrons might randomly swash over to the left side of the oil molecule. What happens then? The left side of the oil molecule briefly becomes slightly negative. And because the electrons abandon the right side briefly becomes slightly positive. We call this a dipole. Two poles, like a microscopic temporary magnet. Now, what happens when this shifting, sloshing bipolar molecule is hovering incredibly close to the atoms in your skin? It induces a panic in your skin's atoms. The slightly negative side of the oil molecule repels the electrons in the skin directly beneath it, pushing them away. Because the skin's electrons were pushed away, that localized patch of your skin suddenly becomes slightly positive. And what do opposites do? They attract. Instantly, across that empty, repulsive void, a microscopic, invisible bridge of electromagnetic attraction forms. The positive patch of your skin pulls desperately on the negative patch of the oil molecule. A fraction of a second later, the electrons swash the other way. The poles reverse. The left side becomes positive, the right becomes negative. But the skin instantly reacts again, its own electrons shifting to match. The dance continues. The oil is not touching your skin. It is caught in a magnetic tractor beam. It is locked in a hovering hostage situation, chained to your hand by millions of temporary, flickering, sloshing lines of electromagnetic attraction. The repulsive forces are keeping the atoms from occupying the same space, but the van der Waals forces are reaching across the void, holding them together. That is what dirt actually is. When you fall in the mud or touch a greasy car engine, the dirt does not touch you. The complex molecules in the mud get close enough to your skin that these van der Waals forces, these shifting, sloshing tractor beams, grab hold of them. You walk around covered in a floating aura of atomic debris held captive in your personal electromagnetic orbit. Now, let's go back to the mirror. Let's solve the paradox of the fingerprint. You have oil and sweat molecules held captive by the weak, flickering tractor beams of your finger. You move your finger toward the glass of the mirror. You must understand what glass is. Glass is made primarily of silicon dioxide. It is an incredibly rigid, highly structured crystalline lattice of molecules. And unlike the chaotic temporary sloshing of your skin oils, the molecules in glass are highly polar. They have strong, permanent electrical imbalances built directly into their structure. As you push your hovering finger closer and closer to the hovering glass, the gap between the two massive repelling electron clouds gets smaller and smaller. The oil molecules are now trapped in the middle of no man's land. On one side, they feel the flickering, weak van der Waals tractor beams of your skin trying to hold on to them. On the other side, they suddenly feel the atoms of the glass. And here is the absolute secret of the fingerprint. Glass is simply a better electromagnet. Imagine holding a small piece of iron attached to a weak, cheap refrigerator magnet. Now imagine walking past one of those massive industrial electromagnets they use to lift entire cars in a junkyard. What happens? You don't even have to touch the industrial magnet. As you get close, the massive magnetic field of the junkyard magnet reaches across the empty space, completely overpowers your weak refrigerator magnet and violently snatches the iron right out of your hand. That is exactly what the mirror does to your biological oils. When the oil molecules get close to the silicon dioxide, the glass reaches across the atomic void with massive, powerful electromagnetic hooks. It grabs the oil molecules and violently rips them out of the weak tractor beams of your skin. You pull your finger away. You think you left a stamp. You didn't stamp anything. You engaged in a molecular tug of war across an empty vacuum, and the glass won. The oil stays behind, locked in a brand new, much stronger hostage situation with the mirror. You didn't get the mirror dirty by touching it. You got the mirror dirty by bringing a captured field of debris close enough for the mirror to steal it from you. This explains the mirror, but it brings up another question from the comments. Someone asked, if dirt is just held by weak tractor beams, why is wet mud so much harder to get off than dry sand? Why does water make things stickier? It is a brilliant question. If you drop dry sand on your hand, you can just brush it off. The van der Waals forces between the dry silica and your skin are weak. A simple flick of your wrist provides enough kinetic energy to break the tractor beams and the sand falls away. But add water and suddenly you have mud. Suddenly it clings to you. Why? Because water is the ultimate chemical saboteur. Water is H2O. 2 hydrogen atoms, 1 oxygen atom. It is shaped like Mickey Mouse's head. The oxygen atom is the big head, the hydrogens are the 2 little ears. But oxygen is incredibly greedy. It hogs all the electrons. It pulls the negative electron cloud tightly around its head, leaving the hydrogen ears exposed and positively charged. Water is a permanent dipole. It is a permanent, highly effective molecular magnet. One side is strictly negative, the other side is strictly positive. When dirt gets wet, the water molecules invade the space between the dirt and your skin. Because water is so polar, it acts as an electromagnetic amplifier. The positive hydrogen ears grab onto the negative sloshes in the dirt. The negative oxygen head grabs onto the positive sloshes in your skin. Water builds a massive interlocking chain of powerful electromagnetic bridges connecting the dirt to you. Dry dirt is held by weak, temporary sloshing forces. Wet dirt is chained to you by highly organized permanent water magnets linking hands across the void. This is why mud sticks. This is why glue works. Glue is just a liquid engineered to form incredibly strong electromagnetic bridges between 2 repelling surfaces, locking them together in a frozen tug of war. But this raises the ultimate terrifying question. If the dirt is chained to you by magnetic tractor beams, how do you ever actually get clean? If you just run plain water over greasy, dirty hands, the grease stays. You can scrub all you want, but the water just slides right off. Why? Because water molecules love each other too much. They are so polar that they only want to stick to other water molecules. They look at the non-polar, uncharged structure of grease and oil, and they refuse to interact with it. Water's tractor beams slide right past the oil's tractor beams. So you grab a bar of soap. If soap never physically touches your skin and never physically touches the dirt, how does it rip the dirt away? Because soap is a microscopic weapon. It is a chemical crowbar designed by human ingenuity to hack the electromagnetic force. A soap molecule is called a surfactant. It is a masterpiece of molecular engineering. It is shaped like a snake. The head of the snake is highly charged. It is hydrophilic. It absolutely loves water. It wants to grab onto water with massive electromagnetic force. But the long tail of the snake is completely uncharged. It is hydrophobic. It hates water, but it absolutely loves oil, grease, and dirt. When you rub soap and water onto your greasy, dirty hands, you are launching a microscopic invasion force into the void. The uncharged tails of the soap molecules dive head first into the hovering layer of grease. They wedge themselves into the gap. They use their own van der Waals forces to grab the oil molecules, wrapping around them, prying them apart from each other, and pulling them away from the skin. Meanwhile, the highly charged heads of the soap molecules are sticking out into the water, desperately grabbing onto the passing H2O molecules. The water pulls the soap head. The soap tail pulls the grease. The tension builds. The electromagnetic struggle in the void reaches a breaking point. Finally, the pull of the rushing water becomes stronger than the tractor beams holding the dirt to your skin. The soap violently rips the grease out of your skin's orbit, but it doesn't just let it float free. The soap molecules completely surround the dirt, forming a tiny floating spherical prison called a micelle. The dirt is trapped inside, surrounded by water-loving soap heads. and the water washes the entire captive package down the drain. No physical contact was ever made. Your skin never touched the dirt. The soap never touched the dirt. It was just fields of energy competing for dominance, a war of electromagnetism fought in the atomic void. When you finally understand this, when you stop seeing the world as solid blocks of matter bumping into each other and start seeing it as it truly is, you unlock a terrifying and beautiful superpower. You stop being confused by the world. You stop asking broken questions. You can start reading the hidden layer of reality. And to help you do exactly that, I have created something for you. I call it Feynman's Invisible World Blueprint. It is a free, downloadable prompt pack and workflow designed to train your brain to stop seeing objects and start seeing fields. Whether you are trying to understand why a wine stain won't come out of a shirt, why a saw cuts through wood, why magnets repel, or why your tires grip the road, this one-page system forces you to strip away the illusion of solid matter and ask three simple questions. What are the fields interacting here? Where is the dipole imbalance? What is the energy transfer required to break the beam? If you are a student, a tinkerer, an engineer, or just someone who refuses to accept the biological lies your brain tells you, you need this. It is completely free. The link is the very first thing in the description below. Download it, print it out, and change the way you see the physical world. So, let's ask the final question, the one that might keep you awake tonight. Are you ever truly clean? You wash your hands, you scrub the grease away, you destroy the tractor beams holding the mud, you dry your hands on a towel. But as you pull your hands away from the sink, you are already walking through a thick, invisible soup of floating molecules in the air. Dust, pollen, microscopic skin cells shedding from other people in the house, vaporized oils from cooking. Your skin is constantly fluctuating. Your electromagnetic fields are constantly sloshing. As you move through the room, your personal Van der Waals tractor beams are reaching out into the empty void around you, grabbing stray molecules, snatching them out of the air and trapping them in your orbit. You are never a completely isolated, pristine object. You are a highly organized, localized disruption in the electromagnetic field of the universe. You are a hovering entity moving through space, constantly exchanging trapped clouds of atomic debris with the world around you. You aren't dirty, you aren't clean. You are just a magnificent matrix of forces playing a perpetual game of quantum tug of war with the void. And that is far more beautiful and far more profound than anything your common sense could ever invent. Don't forget to grab your free copy of the Invisible World Blueprint in the description below to start decoding the quantum reality of your own life. Never accept the illusion. If this video successfully broke your biological intuition and made you see the invisible forces surrounding you, hit the subscribe button. We have a lot more comfortable illusions to dismantle. I'll see you in the next one.